This lesson is on multiple representations. And on multiple representations, we have an occurrence. So here is our occurrence, two bicyclists. Here is a motion map of our two bicyclists. And then here is a graphical representation of our two bicyclists. There's also a written explanation that we could use. And all of these come together as multiple representations. Suppose that we have a stroboscopic picture of a car moving to the right at a constant velocity, where each image revealed the position of the car at 1 second intervals. So first off, we're going to say that this car is moving at 1 meter per second. That's very slow for a car, but it will help us with our understanding of how all of this is put together. So what we're going to do is we're going to start off, I'm going to draw on the car themselves. And so here we have the center of mass of car 1, and it has a particular velocity. And I'm going to draw that motion map down here. The dot represents the time, and the arrow represents the velocity. And when we continue, we start to see the motion. So each new dot is a new position, and the arrow is the velocity. And when we are done, we get something that looks like this. Notice that each one of the arrows that I drew is roughly the same length. They should be the same length. And I'm kind of corresponding to the center of mass. So we're starting here, moving to here, then to here, then to here. All right, now what we're going to do is we're going to, since we've made our motion map, we're going to translate our motion map onto a position time graph and a velocity time graph. So before we can do that, we have to label and scale out our axes. So we're going to make time the x-axis for both of these. And for both of these, we're just going to keep it as a 1-to-1 ratio, and we're going to say these are happening at 1 second intervals. And then the only thing that's going to be different between the two is the first graph is going to be for position, and the second graph is going to be for velocity. So when we make our position, again, we're going to say 1, 2, 3, 4, 5, and 6. So now what we have to do is we're going to have to graph that according to what we have for our motion map. So for our first second, we're going to go, since our velocity is 1 meter per second, we're going to say that this goes from here to here in 1 meter. So I'm going to go ahead and draw that. So here's our 1 meter. Then we have our second position, and our second position is the green one. And so when I make the green one, it's going to go from this position to this position. And the next one's going to be our blue. Our blue is going to go from here to here. And then finally, we have our purple, and our purple will go from here to here. So now that we've made our position versus time graph and everything is organized, next is our velocity time graph. So to set that up, though, to set up our velocity time graph, we have to make this is our 0 line. So we can have positive velocity or negative velocity, but this is 0 velocity. This is -1, -2, and -3. And going up, we have +1, +2, and +3. So we have to look at each one of these individually. So the first one, the slope, I'm going to write this on the side, slope of position time graph is velocity. And I kept it simple for the first one because each one of the slopes for the position time graph, this one, this one, this one, and this one, they're all 1. That makes things easier. Now, it's not going to be always the case, but we're going to keep it simple at first and get more complex as we move on. So the first interval is 1 meter per second. The second interval is going to be, hold on, get the right color. Second interval is also going to be 1 meter per second. The third interval, 1 meter per second. And the fourth interval is 1 meter per second. So that's how you make your position time graph, and velocity time graph based off of a motion map. All right, here is our next situation where we have a car that's going, same car, but it's going a little faster. So we're going to say that this time the car's velocity is going to be 2 meters per second instead of 1 meter per second. So, again, the same way we get it set up before, we're going to start with the middle of the car, which represents the center of mass, and it's got a particular velocity. This time the velocity is going to be greater, so our arrows are going to be longer than for the previous problem. So there's the first strobe, the second strobe, and then finally, we're going to have our third strobe, where it comes here, over, and here, and over. So, now what we need to do is set up our x and y axis for a position time graph. So we have time here, and we have position, and our time is going to go from 1 to 6 again. And our position will also go from 1 to 6. So, starting off with our first one, since it's going 2, we're going to start at the origin and go up to 2. So there's our first one. Then we go to our second one, which is going to start at this position, continuing, but it's going to go up to that position. Then finally, we have our third one, which is going to start at this position and go up to there. And that's our green arrow. Next, we're going to look at our velocity time graph. So time still is in the bottom, same times as before. And then our velocity, just like in the other one, you're going to have your positive velocities and your negative velocities. But in the middle, you have your 0. So the 0 is actually at the middle and not at the bottom. So you got 0 there. We got +1, +2, and +3, and -1, -2, and -3. So the first situation, we have this section right here. So it's got a slope. The slope is going to be 2. So we are going to draw a slope. We'll have our velocity of 2 for the first second. So we go on to our blue section. And then here's our blue section. We're going to start at 1 second also, from 1 to 2 seconds, 1 to 2 seconds. And it also has a slope of 2 meters per second. So we include that for that section there. The last one, we have the same type of deal, except it's going to be for the last section, and the time is going to be from 2 to 3 seconds. So that'll be from 2 to 3 seconds, which is here. And that's how you do this section.